believe last time she was in India. This time she'll be there again, I assume, unless she's moved. So that'll be fun. Remote talk, of course, obviously. We about ready for this thing? Yeah? Okay. All right, well, you guys, I think everybody knows the format here. Lightning talks, you get 5 minutes. So the speaker will have their timer right here. Don't start that yet. Oh, wow. That works. So that's the piercing sound that you'll hear. And that will also be the cue for the audience to erupt into rapturous applause. Yes. And I'll try to help with that. So let that put the fear in you, Lightning Talk speakers, to not go over that 5 minutes. We're very serious about this 5 minutes. And you will be run off this very small stage by the rapturous applause of the audience. So, without further ado, why don't you guys give a round of warm applause to Jay Baker.
Already started? Oh, great. Awesome. Everybody, I'm Jay Baker. I work for B&L Consulting. I'm a DevOps engineer there. And I'm going to talk about introducing DevOps at your organization from the perspective of just your average Joe programmer, operator. So first thing that's going to happen when you try to introduce some of these new topics, new tool chains or methodologies or workflows, management, your coworkers are not going to get it. They're not going to like it. They're going to be resistant to change. There's probably formal structures, processes at your organization that are going to be resistant to any type of change. And then even when you do convince people that, hey, actually these things are good, continuous integration, continuous deployment, that sort of thing, they'll think they already do it. So just expect that there's going to be a lot of resistance. But really what you want to do first is build consensus, right? You know, in this world we always think about, oh, I just, you know, it's ones and zeros. You know, I'm just going to show this perfect tool and everyone will get instantly how great it is and they'll adopt it because it's right and I'm right and that's the end. Well, that's not how it works. An IT organization, like any other group of humans, is a little tribe and you got to play politics. So build some consensus. You know, push for cultural changes. Just gather with your friends at the workplace who have a shared interest, who want to see the same changes that you do, and strategize and think about how you can, you know, spread that message. So basically spread DevOps propaganda, really, you know. But then, of course, you do also need to actually do something. It's not enough just to run entirely on buzzwords. You need to have something to show, something to go with sort of this consensus that you're building, this, you know, cultural change that you're pushing. So the best thing to do is to start small. Find something very simple, some kind of pain point that you could easily automate or find a solution for. Or if there's a little one-off research project you get approved on, maybe start from the beginning on that using some of these methods. And then once you're at that stage, once you're able to actually sort of introduce some of these things and show that, hey, actually, you know, if we do some automation, if we adopt containerization, you know, if we're going to try to follow 12-factor apps or whatever it is, you know, whatever your specialty is for. Once you're at that stage, I think the next step is building up a platform. This is something that we've realized at my own company, and I've seen at a lot of other places as well, is that as soon as you can, as soon as you've got enough critical mass and enough buy-in from management and whatnot, you're going to want to start strategizing long-term about building up a platform that's going to be as all-encompassing as possible. The more of those decisions you can make and codify and have done and taken away from the conversation, the simpler things are going to be moving forward. Finally, don't ever stop experimenting and trying some new stuff. There is no one great way to do the DevOps. It's going to be rapidly changing. You're going to need to keep finding new things to incorporate, testing out new tools, new ways of thinking about things. You're never going to be done doing it. And always go back, not only to older legacy systems and processes, but also that first automation test that you wrote, or that first Terraform repo where you're codifying your infrastructure. Once you've achieved some success, go back and say, oh, actually, this is crap. I need to, it was good at the time, but really I need to redo this now that I understand really how these tools work. And that's it. So thanks for listening, guys. I'm up on the 7th floor. Come see me sometime.
All right. So, yeah, I noticed that. Yeah, the timer stopped. The timer froze at 3 minutes and 3 seconds. So, you'll forever have 3 minutes. Paul. What I learned was that containers are something that live on boats in water. Okay. That's what I got. Kyle, why don't you go ahead and hit that OK button there and hit it. Wow, that is a beautiful thing. That was me. Before I knew. Yeah. What's going on there? Nothing? Good? Oh. Yeah, it is.
Yes, you will.
That's a big win right there. Round of applause for Jay, everybody. There we go. MVP.
All right, let me into the mic. Very best. All right, so if it pulls up, maybe. There it goes. Okay, so basically the thought here was we're called on to use email in our applications, and there's lots of different sort of implementations, ways to use it. We're in email marketing. So what is it that I like to talk about? What do I think about a lot? It's email marketing, and who do I interact with? It's email marketers. So I had this idea. I was like, what if I created a space where email marketers could share with developers what they wish we knew? Does that make sense? So I connected with a bunch of my friends online, and I said, just what is it you wish developers knew about email marketing? And so Cosmin, he's a email marketer from Hewlett-Packard. Honestly, I didn't put everyone's, he was mad that I said hardware vendor or OEM computer manufacturer. He's like, put Hewlett-Packard. All right. So he says, I tell them that you can do and get so much more with HTML emails as opposed to plain text, right? He says, I know that we'll hate it mainly because of the bloated, dirty code and tables, and if you've ever looked at HTML-based emails, it is ugly. HTML 3.2, I think. I mean, there's a little bit you can do, but it's ugly, right? And so he says, most would wish just to send out that email in plain text, but email is much more sending a text communication. Emotion plays a critical role. Okay, After all, the apps they build aren't plain text, are they? Okay. So this Wasif, friend of mine, he just wanted to tell a story. He's like, I built this really cool email, and he's like, you can't use HTML5 or JavaScript or really anything cool. He's like, but if you really, really, dig in, you can put something together that's pretty cool. He says, so I did a horizontal email for a large bank, and the real key here is this click-through rate over 100%. I said, that's probably not unique click-through rate, right? Because we compile the click-through rate based upon unique clicks, unique individual subscribers that click on an email. Now, my friend from Red Hat is where she's from. She said people consume email content differently than web content. And so she goes, I have to tell my marketers all the time that email is not a landing page, right? So we have to think about it a little bit differently. Like, where do we view emails now, promotional content? Mobile first. Mobile is a huge issue in our space, right? Because that's the primary reading mechanism now. My friend Elliot, he's works for a company over in London, actually. He says there's still a myriad of email-specific bugs to be aware of, though. So he says I'd stop short of implying that web code is okay, because it's not quite the same thing. My friend Nick, who works at a big hotel chain, says, tell them about litmus testing, okay? This is not all about just design HTML code, by the way. Litmus testing. There's a million different email clients. Gmail, Outlook, Hotmail, Yahoo. We can keep going. I've already lost interest. But what Litmus does is it takes all of those, you push in your HTML code, and it renders what it will look like in the actual device. So you can see Apple Mail, Outlook, all of those, and you want sort of a universal look, right? And so you can see mobile, you can see iPad, etc. My friend Kevin, who actually works at Litmus, wrote, it's not that bad. There's a lot of old myths out there. He's like, 99% of clients now support embedded CSS. That's cool, that's good. 80% support media queries. So you can just use divs for layout structure, except for Outlook, Windows. Because welcome to our world. And then just use conditional comments for Outlook table fallbacks. Devs make 1,000% easier. Nathan, who's works out of a large e-commerce retailer out of Canada, he said, we don't have an undo button in email. If you drop 10 million emails at a given time, you just sent out 10 million emails. I was doing a test email at one point, kid you not, and the content of it said, your feelings are stupid and wrong. I think I sent it out to 10,000 people. Yeah, not my best day. Anyway, one of the things that we've done, this is the only plug for Audience Point. We deploy email over time using send time optimization, figuring out the best time. So it builds some risk mitigation in commercial over. Even worse than normal dev work for compatibility, which we already talked a little bit about. And he also said, make sure you talk about the importance of mobile. Okay, why should you test email? This is a Red Hat Linux email. She said, just tell them you got it in your inbox. So this is what it looked like on the client that they had tested in. This is what it looked like on the other one. She was like, So when you get this in your inbox, you go, ooh, that's really bad, right? Because you go, they don't know what they're doing. It's important that our emails render correctly. All right. Nick, we talked to him a little bit ago here. Trust and learn from the analytics. It's really important in email. You should always design code for mobile regardless, but it helps have facts to win an argument. If you have data that shows percentage of opens in games, capture it. Also, personalize. There you go. He also said it takes, if IT team's full of .NET and CS peeps, whether or not you are or not, doesn't matter. Time expired. My bad. I got one more screen to show about sending email on your own, because this is something that I would do. It has all kinds of your internal IP addresses, and just don't do that. That's a corporate email I captured.
All right, thanks, Paul. Caleb, come on up. I need a big cane for this. I need one of those big, comically long canes to pull people off stage, you know. Remember that gag? Ready thy hand, Kyle. I said, ready thy hand. Steady thy hand. Of a browser.
Close? All right. So my talk's on WebAssembly, and today we're going to be hunting wabbits. So WebAssembly has a lot of funny acronyms. Before we get into that, explain a little bit about it. So everything is written in JavaScript, right? We've got Atwood's law. Absolutely everything that can be written in JavaScript will be written in JavaScript. Turns out lots of people don't like that. So we decided to come up with WebAssembly. And it's been in the works for a couple of years, and early this year, it was decided to have been completed as an MVP and to be shipped by default in browsers. Basically, the understanding being we can't really work on the spec anymore until we've got it being used in the wild. So what makes up WebAssembly? It's this JavaScript API in binary format accompanied by a reference interpreter. Some of the terminology, we have WASM, this was WebAssembly, the WAST, which is the abstract syntax tree for WASM, which is what you write, OWAVM, which is the WebAssembly virtual machine, just like V8, except for WebAssembly, and WABIT, which is the WebAssembly binary toolkit, because you have to transpose all of these different pieces of text into the binary format that runs as WebAssembly in the browser. So WAST is written in an S expression syntax, and it has to be translated down to binary encoded WASM first. So let's get into what some of the code looks like. We're going to do a hello world WASM and go through a little bit. So here, we import a standard lib print function from JavaScript. We also import a piece of memory that is one page, 64 kilobytes. The piece of data that we're storing at memory location 0 is the string hello world. We're going to export a main function that just takes the memory location from 0 to 11 and passes it into the print function that we imported on line 2. Anybody need me to leave that up for a second longer? So we can run this in both web and web first. So remember how we were importing the standard lib earlier? That's the exposed variable that we have right there. We're just saying we want to expose that print function, which is log defined up there, takes a memory offset and a length. That part's pretty simple. We also pass in the memory, which is created by WebAssembly.memory initial. The initial page is just 1. We only need 64 kilobytes of memory. That's what Bill Gates said, right? No, it was 640, something like that. In any case, that's where the hello world is getting stored, and we pass it on down here. We go and fetch the WASM, we get the response, turn it into an array buffer, and then instantiate the WASM with that exposed object right there, which gives us our standard library and a chunk of memory, and then we just call main. So that's how you get it. You get the instance, it exports that main function, and then it just runs. So what's wonderful about this is let's go take a look in the browser. Oh. There you go. We've got a hello world. That is WebAssembly running in the browser. And what gets better is it already works in Node. So this code has been transposed a little bit. We don't even, used to we had to pass in -- expose WASM. Now we can just call it bare. Let's take a look at what the Node code looks like a little bit. It's going to change a little bit, as in the web we have text decoder, and in Node we don't. We're just going to do string decoder, UTF-8, pass in the bytes to the buffer, tell the decoder to write that. Essentially, we're taking that memory buffer out of the WebAssembly from when it puts in the string, and then put it back out, and then console log that byte buffer. But everything else is generally the same. We have a WebAssembly memory that we get right there. There I have an initial 20. That's going to give you, so like 20 more pages worth of bytes. And we just call the exported main function again. It's really simple. This WAST is what you would be writing, most people are going to be using some sort of LLVM to compile down to this type of code. And you shouldn't really ever have to write this yourself. And shameless plug, I don't like writing JavaScript, so I decided I wanted to write a programming language that compiled just to WASM with no pass-through through the LLVM, no intermediate representation or anything. Rumling.org, docs.rumling.org. That's about it. That's WASM. $11 Oh man, I feel good.
Impressive time management there. Good stuff. Tom, a round of applause. Yeah, come on. Come on, guys. Gee, yeah. Ah.
All right, so here we have another talk about JavaScript. This is a very short talk. And it's kind of a challenge to me because I personally find it very difficult to say positive things about JavaScript. So here goes. I could make it happen. So this is what we're going to be talking about. This is the teaser. This is the thing. Yeah, we'll cover that in a second. But just first, I want to say why this talk is so short, and it's because, well, you get the idea. So before we talk about that new hotness that I gave you a tease of, I think it's helpful to give kind of some context of where JavaScript came from in terms of, loading another JavaScript file, right? So you have loaders of all shapes and sizes from all sorts of points in time back along with the initial implementation of script in HTML 4.01. That was 1999. You could add scripts to the page by, guess what, adding more script tags. This is lovely. But this isn't quite what we want. It'd be nice if we had a programmatic way of doing this, and there have been some library implementations that have come along since then, jQuery being one of them. jQuery actually had the get script function back in its initial 1.0 release, 2006. So here we have this one. You guys know this one. There's this crazy guy. His name is Ryan Dahl, and he's got this great idea that he's going to take another stab at JavaScript on the server, and so he makes Node.js that includes two separate loader functions. One is include. Include inserts the exported objects into the global namespace, and require is like that, but it does not pollute the global namespace. So that was there in the very first 0.0.1 of Node.js. 2010 comes along, we have require.js. Very similar, it's just a little different module format, but more for the browser and not for the server. And then finally we have, well, not quite finally, but ES6 here in 2015, or ECMAScript 2015 if you will. This comes along here in the year 2015, as you might have guessed by the name, and it introduces the import keyword into JavaScript. So what's the deal here? Why is this not enough? Why do we have another thing over here in 2017? And the reason is it's not enough because you can't actually use it, right? You've got to have a whole bunch of client-side tooling or build time tooling to make this actually work. You've got to have a transpiler to take that import and mangle it into something that your browser can recognize. I don't consider this acceptable, me personally anyway. So here we have it, 2017. The time has finally come. We have script type equals module. So this gives you no browser flags, just plain JavaScript modules in your browser. And really just the point of this talk is to make you aware that I wouldn't want you to think I'm not happy about this, right? This is a very welcome improvement to the JavaScript ecosystem, and I think it's wonderful. And you could use it today. You could use it in these browsers, right? So there's still a lot of red on this page, but Edge, Chrome, Safari, all today, the current version of those browsers will let you use that. No flags, no nothing, just the current stable version. So there's those versions. Safari was the first one. They beat out the other browsers by a couple of months. I think that is very interesting to see how Edge actually beat Firefox. That's surprising. So this is great. And next we have some examples. So this is a script type equals module tag. You've got native, actual, real imports. You can call functions from your stuff that you imported. It's really lovely. This works in the browser and it's great. Similarly, you could have a separate exported module from a file, which you could call in that way. That works as well. So it just works like you would expect. That's all that I ever wanted from JavaScript, is for it to just load a dang file in the browser, and it's wonderful. So a couple of limitations here, though. First and foremost is you cannot have a bare import specifier. So this part right here, the from guy right there, that's the import specifier. And the thing that you can't do is you can't say, just give me jQuery. That's not going to work. It's got to be relative or an absolute path. So that's up to browsers to figure out what they're going to do there. And then final limitation here is that you cannot dynamically import something. So there's no such thing as a conditional import. You've got to stick that stuff all the way up at the top of your script. And the browser will statically analyze and include it in there for you. So in conclusion, this is great. And if I've learned one thing in JavaScript, is that things could always be worse.
Excellent time management there again. Wow. Right under the wire. Jared? Oh. Oh, that's early. Wow. Cutting yourself short there.
So I've asked Paul. Hey guys, I'm Jared. This is Paul. He's coming back for round 2. I asked him to help me out here on this talk. Let me plug in here to this fancy USBC dongle. Please hold. All right. 1 second. I can't zoom like I thought I could. Oh, whoa, all right. I think my computer's like gonna crash here or something. Oh, power, that's exactly what I'm gonna talk about. Thank you, Paul, that will actually be helpful. I just want the cable though. All right, so with USB-C, my coworker has a USB-C 15-inch MacBook Pro as well, and I wanted to figure out how to charge this laptop with his laptop, just in case like mine was dead or something and his wasn't. So could you plug your USB-C cable into your laptop, then plug it into my laptop port? So I tried this, and last time I did this, it didn't work. So let's see, can I, here, I don't know why this is. All right, so he's plugged his laptop into mine, and it is not charging. I am. You are. What? It did not work this way last time I tried it. So last time I tested this, it didn't work. Like, it gave me this weird error saying that like it couldn't talk to the Thunderbolt display. Man, should have like practiced this before I did it. But basically, I found that if you use a dongle and then plug that dongle in for me real quick here. Other way. That's here. Go. Okay. I'll hold your laptop. You plug in the dongle. All right. Now plug the dongle into my laptop. Damn it! It's not working like I thought it. Okay. Come on now. Think reverse the cable. It shouldn't matter. Okay, how this has worked for me in the past is that by using the dongle, it added a layer of indirection to the charging system so that this end of the dongle requested power, this end supplied power, and it allowed me to charge 2 laptops. But his is taking it. Maybe it's because it's a different laptop. So maybe, okay. So if you have the same device, you can use a dongle to add a layer of indirection to charge your laptop. And quick little side note. So since this guy has a 75 watt-hour battery, and since Apple says that it should last 10 hours, it's a lie, but let's just pretend that it does. That means it uses 7.5 watts on average, and the power ports can supply 15 watts, which means that if Apple is telling the truth, and if you use a dongle, then you should be able to charge this laptop on 15 watts instead of on 87. So, rehearsals, practice, makes perfect. Thank you.
Andrew.
All right, it's me again. I'm going to talk about something I know very little about. Hopefully, we'll all know more about it by the time I'm done. So I recently attended a conference in Washington, D.C. with a bunch of folks from very large research universities, the folks that run Internet 2, research and education network operators from around the country. And they were talking about the missing pieces in operationalizing software-defined networks. So what are the problems that, as a community, as operators, they're facing that are preventing them from really going to full production with SDN, moving all their traffic to SDN networks. And the topic that kept coming up and up and up and up and up again was, we need traceroute for SDN. And in my opinion, that's kind of a misnomer, because traceroute is a way to investigate, interrogate a distributed system about which you know nothing. And the whole point of SDN is to provide a centralized, and does everyone know what SDN is? Software-defined networking. So the idea is kind of giving you the same programmability at the network level that we all enjoy in our cloud infrastructure, our infrastructure as a service, platform as a service, all that sort of thing, but giving you that level of programmability and that level of flexibility, not being limited to specific network vendors, hardware functions, giving you kind of abstractions that allow you to, like JavaScript for network. Just for all my JavaScript fans in the room. So anyway, as I sat there and started thinking about this, the thing with traceroute, the reason why traceroute works is because you have in-band communication that you can use to interrogate and get information from the network components that your traffic is traversing. And on a SDN network, the whole goal is to abstract and separate the control from the data plane. So you really don't have access to the equipment from the data plane where your traffic is moving. So it's really hard to use something like traceroute because there's no way for it to interact with the router, get information, send it back through the data plane to you as the user. But that's what everybody wanted to do, and everybody was trying to think of, how do we build interfaces at all these pieces of equipment that will allow us to access each other's, which just, when you look at this, the scale of the entire internet, or even the entire research and education network internet, that just gets crazy complex, crazy fast. But what I realized was almost none of them actually even had true telemetry deployed in their systems, at least in a way where they were getting real observability of the network. So it seemed, so the whole point of this next 2 minutes is to kind of posit this thing that I'm throwing at everyone, because I'm not going to build it, but hopefully somebody builds it, and maybe somebody will get interested here in this stuff. the idea that, you know, each domain needs to have good standardized telemetry about what their network is doing at a campus level, at a research education network level, and even at a national fabric like I2 level. Then you can worry about federating metrics without having to worry about giving control of your domain equipment to someone else. So this just like SDN abstracts, and there's no, like, the reason why there's no slides to explain all this stuff is I'm just trying to fill a slot here, but I do think this is interesting, and I had this diagram already made. Just like SDN abstracts the data from the control, this would abstract troubleshooting, understanding, interrogating the network from controlling the network. And so the idea here is that a trusted party could operate a federated application, which a lot of these folks already have arrangements like that for other pieces of their systems, that would allow, you know, if I'm provisioning an SDN flow from this campus, this federated application would know which pieces of equipment that my flow is touching and give me metrics and access to data from those pieces of equipment that would allow me to troubleshoot problems with my flow. So that's the idea. It's a federated, standardized telemetry system for software-defined networks at scale. I have 18 seconds.
We'll see if it works. All right, can everyone in the back hear me? Okay, shaking their heads. All right, so today we're going to talk about a country in the Balkans. It's Estonia. Everybody knows where that is, clearly, right? It's slightly south of Finland, so it'll be you know, in Eastern Europe. Now, Estonia, as you can see here, is a beautiful place. It has a very rich culture, history. We're not going to go into too much detail about that, other than say that it used to be a Soviet country, and after the USSR broke up, they became their own independent nation, self-determination, all that good stuff we love. And they decided in 2000 to make the internet a fundamental basic human right. Everyone has access to the internet, if the government can help it. Along with that, you know, several of their public services are available online. You can report crimes to the police online, vote, etc. A few things you still have to do in person, but for the most part, you're able to register a business, file your taxes, do anything you would want to do as a normal civilian online. Businesses can start up in, say, 20, 30 minutes. They also have a concept of a national ID, which is cryptographically considered secure. There was a recent story on that, so I know we'll ignore that story for now and pretend it's still totally secure. But anyway, they addressed this 20 years ago, and now it's something that needs to be updated, like commonly needs to be done in security. So clearly, what could go wrong? Unfortunately, they had a situation, being a ex-Soviet country where hackers with bananas decided that they were going to retaliate in response to a city in the capital, or the capital, deciding to take down a Soviet-era World War II statue. Now, after they decided to do this, there was an initial attack, a test attack, on April 28th. This test attack downed the national newspaper and was a proof of concept that you know, the country certainly was vulnerable to a DDoS attack. On May 8th, multiple websites noticed 200 times normal traffic and essentially knocked off their national paper, online banking, and multiple websites. And this attack continued for 2 weeks, eventually being called off by unknown controllers, and the Estonians were able to reestablish control of their local sites. So the Estonians were, in essence, brought to their knees because of their dependency on their technology. So what did they do? there was a local company that decided to invest heavily in blockchain technology and implement a blockchain on the national level. And in response to this, Estonia decided to invest at a federal level on several mitigation strategies. So they did get the first NATO-accredited cyber defense center in country. They do have a off-site data embassy, I believe, in Luxembourg. The idea there is if they're ever attacked again, they can reboot remotely using the data that's stored off-site. That's data for the entire country, which would include their laws, it would include tax returns, etc. It's also the first country to use blockchain on a national level. That way, if there is a bad actor or anybody that attacks them internally, they would be able to identify and roll back any issues they experience there, hopefully. It's also the first, it's a leading country in Europe as far as this metric. It's essentially a high school level exam that tests your capability in science, math, and other key metrics, and they're a leader in Europe. They do plan to roll out 5G network capability next year, obviously not related to security necessarily, but I thought it was kind of cool. And 10% of their students study IT, so they've definitely invested at a social level, economic level, in their information technology, and it's paid off. They're a little bit smaller than Tennessee. Financially, they're nothing outstanding. They only have, I believe it's 4% of their 7% of their GDP driven by IT. So it's definitely not an overwhelming part of their infrastructure, but it is an important component and something that I believe a small population, like say even Tennessee, could replicate. And well, thank you very much. That leaves me with 15 seconds.
Last but not least, Brandon Schwartz. Round of applause for Brandon.
Hi, y'all. I'm Brandon, and I'm displaying on the wrong screen. So today I'm not going to be talking to you about F#. May not be talking to you about anything. Let's just see. Today I want to share that I think we can do better than Fizzbuzz. Who in the room knows what Fizzbuzz is? Okay. For those of you who don't, it's typically an interview question. I used to think typically for entry-level people. Write me a program that prints to the screen a list of the numbers 1 through 100. If it's divisible by 3, print Fizz. If it's divisible by 5, print Buzz. Now here's the curveball. If it's divisible by both, this is really tricky, print Fizzbuzz. Otherwise, print the number. Just some context for why I'm talking about this. I've been interviewing for a minute. I've had more than double-digit jobs in the field, approximately 517% more interviews than I've had jobs. Age to a certain point, get a certain amount of grace, certain amount of grumpiness. I became a senior dev. Probably in all that time, I've done 4.5 interviews that haven't had Fizzbuzz. I've conducted a lot of interviews. More than 11 of them have not had Fizzbuzz. I found a couple better approaches. Hey, check it out. I wrote Fizzbuzz at 3 a.m. to prove a point. So sometimes I tweet, and I don't get a lot of Twitter activity, a lot of reactions. I may or may not have lit a powder keg with this one. I'd had a conversation with a friend of mine who'd interviewed for a developer lead position, and this sort of strips out all of the Twitter unfriendly and more than 160 characters from what she said. I was amused by it. I posted it. I had over 1,000 impressions from that, which is more than 10 times the impressions I normally get because very few people follow me on Twitter. Hey, look, you can write Fizzbuzz in SQL in like 3 minutes. So how do candidates typically feel when they get Fizzbuzz questions? We will ignore entry-level people who there's a baseline where we have to establish, can you program? People who have received Fizzbuzz in interviews, does anybody feel much differently than any of these? Is anybody really excited to get Fizzbuzz? Right. So I took a poll just to see. I was at Code Stock, I was up late, was curious, said, so how do you guys feel about Fizzbuzz? Pretty much a suboptimal approach, pretty suboptimal. So the way I've always thought about Fizzbuzz, so when I rage quit and I don't want to be a dev anymore and I want to go be a juggling clown, in the interview, they might have me juggle 3 balls. This may or may not have happened last week. The actual job description includes a lovely hand-drawn 1-ton block, an intangible cloud of dust, and the Sword of Omens. But because I juggled those 3 balls in the interview, I got a job offer to juggle swords and 1-ton blocks. Because really, I mean, we need to find a way to benchmark and to judge, you know, is this guy good? Do we want to hire this person based on the strength of our interview? Is he questionable? I'm going to guess most people who pass Fizzbuzz probably fall into this. I'm not going to interview someone and say, you know what, he could write Fizzbuzz. Let's hire him immediately. People who fail Fizzbuzz, I feel like immediately go into the, yeah, maybe not pile, because it seems like kind of a baseline. And I'll back up and say, I'm using Fizzbuzz to sort of cover a class of programming exercises, reverse a string, that sort of thing. It's all Fizzbuzz to me. Look, you can do it in F#. I knew I'd find a way to flip F# in here. What can we do that's not Fizzbuzz? Because we only have a half an hour, in some cases 5 hours to interview someone. We do online tests, written exams that you take home or do in the office, pair programming. Write a bad Fizzbuzz implementation. That'll show me that you understand anti-patterns and we can talk about why it sucks. Code review an old code base and point out things that aren't great. That's sort of my favorite. I've seen that implemented well in a lot of other places. I'd love to hear about good alternatives to Fizzbuzz that other people might have. That, I leave you with a series of let me Google that for you links for better alternatives to Fizzbuzz. Thank you.